So today's week 6. I'm going to open up the application we've been working on. I'll start my server. Make sure I'm connected to the VPN. I'm also just going to connect in FileZilla. I think I've uploaded my files to the AWS web server, but I'm just going to check. And if not, I'll upload the files we've been working on. I don't think I uploaded my files from last week. I'm going to update the server. So I've got my latest copy. I can actually load the application. So I can run my application online. Some of you stuck around at the end of class last week where we did some customizing of the user interface. We overwrote some of the styles. We added minimum font, changed some of the colors. For applications running online, and we can add I can edit or delete. So we have all this create, read, update, delete functionality working. Problem is my site is live now on AWS, so anybody anywhere in the world with an internet connected device, if they stumble across this IP address, they can do anything they want with any of the data. Right? They could add whatever they want in here, they could edit it, they could delete anything. So not many of our applications are going to be like this. We're not typically going to build public sites that anybody can just come to and put whatever data they want or remove any data. So typically we're going to have some kind of access control around who can access things and who can do what. So what we want to do, what we want to have working by 10:50 today, is we want to reconfigure this application so an anonymous user can read this data, but only an authenticated user who's actively logged into the site can add, edit, or delete anything. So we kind of have two versions. There's a read-only site for the public, and then there's a modified version of the site for somebody who is authenticated. So in order for us to implement that, there's a whole lot of things we're going to have to do with this application today in class. So I'm going to give you about 3 minutes to talk to the people at the table next to you, and I want you to make a quick list of what are all the things we're going to need to do to convert this public site into a site where only authenticated users can change anything. So what steps? You're not going to think about the code. What's the process? What will we need to add on to this today in order to make this work? I'm going to give you 3 minutes. Come up with a list of everything we're going to need to do in class today. Adam, you can make your own list, or you can join Nick.
I know, but I'm saying fingerprint sensor. Everybody fingerprint sensor.
Okay, the room is fairly quiet, so I assume you've thought of everything that you can think of. So what would go, ask the table at the back, what's one thing we're gonna need to do? Okay, yes, can you explain that a little more? We'll definitely need one, you're right. Okay, so we'll need to build the login form. So we'll need 2 pages for this, right? A form for the user to enter a credential. It'll post to the server, and then we'll have to check what got entered some way, somehow, okay? Something else we'll need to do? Okay, so okay. So whether they can even see these links or access these URLs is going to depend on who is this person. Are they anonymous or are they authenticated? Yep, so we'll need to modify, for example, this page. We'll need to modify this page as well, right? Because here we've got a link, links, and links. So an anonymous user shouldn't even see those. They should just see a static HTML table with the data. Okay, what else are we going to need to do? Julian? Absolutely. Where would it make sense to store them? Yep, because none of this other stuff is going to work if we don't have a user store. That's probably going to be the first thing we're going to have to do is set up a place to hold user accounts. So that's going to have to go in the database. This is good. We're going to have to do a few other things. We're on the right track. Right. So before we can validate logins, we have to have a way for somebody to be able to create an account in the first place. So again, we'll need 2 pages for this. A form where you can sign up, and then a save page that'll take that account information, send it to the database. Okay, this is most of it. Anything else you think we need to do in order to get this to work? We should do something specific around passwords. Okay. Close. What, Adam, you're right. What you said we want to encrypt the password. Can you explain that a bit more? What is that and why do we want to do it? Okay, so if I type in the password of ABC123, it'll get stored as some long string of random letters and numbers. Now, we don't actually want to encrypt. We're going to do something similar to encrypting, but it's not encrypting. Okay, we want to set up password hashing. What's the difference between encryption and hashing? Right. Any value that can be encrypted, it can be decrypted using the same algorithm. So encryption is two-way traffic from plain text to a random string, but then from the random string, we can restore the plain text. So with hashing, we can never see the original value again. This is why with most applications, what happens when you forget your password? What do you have to do? Yeah, you have to reset it. It can never show you the original password because applications hash your password. They don't encrypt them. So we'll have to set up the hashing, and we'll need this on this page when we save a user, and then we'll also have to hash it on our login validation page as well. So hashing is safer. Okay, that's mostly it. So I'll save those notes. I guarantee you one of the quiz questions from this week's class will be around hashing versus encryption. Which one is safer and why? Okay, so the notes, they're on here. It's in the lesson 6 folder. So if you can click into the lesson 6 folder, the first thing we want to do is set up the table in the database. So we can't do any of the work in the web end of things until we have a place in the database to store user accounts. So in lesson 6, in the middle of, there's a whole lot of stuff on here today. There's this item that says user table script. And I need to make that visible. Sorry. Okay, just refresh the folder. Thank you, Adam. So this will create a simple table in the database. So I'm going to connect to my database. Make sure you connect to the VPN. And we'll run that script. Our user table is going to have 3 columns: an auto-generated ID, a username, and the password. And we're going to make the password field big because we're going to hash it. So hashing is typically going to increase the length of the password. So I'm just going to copy that script and execute it. And then I'll have this empty users table in the database. So execute the script, make sure you get a green check mark in MySQL Workbench, which says I was able to create my table successfully. So the register and login pages, to save us some time, I've actually created these HTML forms. There's no PHP script on them, but I've put these files on D2L rather than us taking the time to hand code the HTML. You can just download both register and login. They're almost the same. We'll download them, we'll look at them, and they should be there and you can't see them. And now you can, sorry about that. So just download each of these into your music library project. I think it will, actually, if you download them, it will download as a zip. I think if you view the item, you may just see the HTML and you can copy and paste and create the file, whichever way you want to obtain them. So if you open the file, the HTML is here. You could just copy it and paste it into a new file called register.php. Register has 3 inputs: a username, where we're asking it to be formatted as an email address, a password, and a confirm password. Login is exactly the same, there's just no confirm password section. So the register page will look like this. And the login page looks almost identical. There's just one less field on there. And the heading and the text on the buttons are different. So we outlined about 7 steps we have to take. We've already done 3 of them. Build a user table in the database, build a register form, build a login form. We've done all the easy stuff. So the next thing we want to do is build. If we open up the register page in our code editor, the form I posted on D2L, it's going to submit to a page called saveregistration.php. We don't have this page yet. So if you filled out your form right now and click register, we'd get a 404 error. It's calling a page that doesn't exist. So we need to create a page with this exact name, and then we're going to need to write the code to create a new user. Most of what happens on that page is stuff we've already done. The only thing we haven't done, I mean, we're basically just inserting a record into the database. So we've done that in this site. You guys have done that in your assignment. It's not very complicated. Hashing of the password is going to be the only extra feature we need to add. So before we create the new user, we want to take the plain text password they enter in the form, and we want to hash it. And then we can look at what that result looks like with that hashing algorithm. So let's make a new PHP file. And it has to have this exact name that we've got in our form action. It should be called save-registration. I know this little box, the font size is hard to see, but it's the same name that I've got highlighted on line 14. So these are all the things we're going to do here. It's, as I said, it's a regular insert into a database with the exception of hashing the password. That's the only, we need one extra line of code. Where should we take the user when this is all done? So if somebody gives us a valid email format and a proper password, we can save them to the database, where should we take them afterwards?
Probably like the homepage, so that would probably be the highest.
Okay, so
That or the
okay. So most of this stuff is going to be things we've already done. So we called our fields. I called the fields on the form: username, password, and confirm. So those are the fields we'll want. Variables I'll create. We have 3 form inputs. We need 3 variables. And I'll give my variables the exact same name as the form inputs. So what validation checks should we run on these values? Okay. I want a fourth variable like we used before. I want an OK variable. I'll default it to true, and anytime we we'll toggle it to false. We will want to check for duplicates. We'll do that after. We'll want to make sure the password isn't empty. And what about our confirm variable? We can actually just do a different check with that variable. Right, so we can just check these two for equality with a double equal sign. We'll use not equals. So if these two variables are not the same, and then we're only going to do all the rest of the steps if we haven't encountered any error. So all of these things are only going to happen inside of our if block. So if our validation is good, PHP actually has a method called, wouldn't show up, password hash. And it takes two parameters. The string we want to hash, and there are some different algorithms we can use. They're different strengths. We want to hash our password value. And the recommended algorithm is actually password default. You can see the different encryption algorithms here, but password default is the one that's recommended. So this will convert whatever plain text was in there into a string of numbers and characters. Yep. Good question. There's a good explanation actually in the documentation, so let's have a look at it. Password default does actually use bcrypt. And this typically, but we'll see how long of a password we get, but it recommends when we created that table, I made the password field 255 characters because it's long. So the one that specifically is called password bcrypt only generates a 60 character string. So this is actually the recommended. And these ones are only available if we're doing compiled PHP, which we're not, so we don't really have access to those. The other thing about bcrypt is it uses salt, and that was deprecated in PHP 7. So this is the current standard as of PHP 5.5. So let's just try this for a minute before we do the rest of the code. Let's just fill out the form and we can have a look at what password hash will actually do. So if we type in a password of ABC123, we can see what the hashed value is going to look like. So we'll leave the rest of the code for a minute. We'll just display what this value is and we'll fill out our form and try it to get some idea of how password hash works. Well, I'll just try ABC123. Later on, we'll want to add maybe some JavaScript to our form to enforce a stronger password. We can just try this out this way. So when I click register, there's our hashed value. Let's see how many characters that actually is. So we get 60 characters from this algorithm, no matter how long the actual password we enter is. So even with a longer password, so if I enter 12 characters, it's still going to give me a 60 character string every time. The other thing that it does, if I resubmit the same password, you'll notice the hash value is different every time. So I actually entered the same password in my form, but it includes some unique identifier in there. So even if we have two users that entered the same password, the hash value that we're going to store in the database is actually unique for everyone. We don't have to do anything to ensure uniqueness. So even though our passwords are only 60 characters, we set up our table for 255 because it said over time, the length could expand depending on how the algorithm runs and how many records are in there. So we're wise to include 255 characters just in case. So now writing the rest of the code here should be simple. It's the exact same stuff we've done previously. Go connect to your database. We don't have a field for the confirm password. We don't need to save 2 copies of the password. We only are using the confirm field in our validation to make sure the user put in the same password twice. So even though we have 3 inputs on our form, we're only saving 2 values to the database. So our username parameter is 50 characters. How long should the password parameter be? It's going to be different. What length needs to go here? Yeah, it should be 255 because potentially your hash value could be that big. Actually, I think what we'll do instead here, instead of taking them straight to the artist page, I'll explain what we'll see a bit why later. I think I want to take them to the login page and make them log in. This isn't a bad idea after somebody signs up because they often want to know that the login will actually work for them. We'll add the redirect after. We want to try this page and see if it actually saves to the database first. And just before I try it out, the one other thing we can add is we can add a regular expression to the password field so that they can't put in a really simple password. We maybe want to ask for an 8-character password with an uppercase, a lowercase, a number, and a special character. Actually, maybe we'll leave the special character out, but 1 letter, uppercase, 1 lowercase, and 1 number. So I'll go back to my register form in a minute, and we're going to add a pattern to the password field. So in our register form, in the password, we have a pattern attribute. So we want a digit. We want 1 lowercase character. We want 1 uppercase character. You don't have to require this, but it's a good idea. And we want it to be at least 8 characters long. We can probably add this to our confirm as well. We'll try this out and see how it works. So now I just put in ABC as my password. My HTML5 validation now says, nope, you haven't met the password rules. As long as I put in an 8-character string or longer with an upper, a lower, and a number, now I can submit the form. Now, once we finish for today, we won't be able to change anything into the site, anything in the site unless we log in. So what I'm going to suggest is create an account with the username test@test.com and the password test1234, where the first T is a capital. This way, we're not going to work with this site again for 3 weeks. So when we all come back in 3 weeks and we think, how do we get in here? I don't remember my login anymore. We'll all create that same login. So you don't have to worry about what username and password you use for the site. I did this as the password. I'll type it here. Test1234. So we'll all use this login, and some of us will certainly forget how to get into our own site. So we'll try our save page now. I'll click on register. There's no error, so that's encouraging. It shows the hashed password. Now we can go and do a quick check in my SQL Workbench and see if it actually saved anything. So now I have 2 records. I suspect someone is connected to my database. That's going to cause a problem. So if you are using my code from GitHub, or you need to put your own database credentials in. Now I'm not going to be able to log in properly because I get 2 accounts with the same username. So I'm going to delete both of those. And try again. We should probably also add a check now. I know that you suggested this earlier so that that couldn't happen. We should do that as well. All right, it's 9 o'clock. So what we should probably do, but we'll do this when we come back, before we run this, we're going to need to run a query to check, is this username already in the user table? And if it is, we'll need to print a message to the screen saying to the user, this username already exists. So we don't get duplicates. Okay, let's take a 10-minute break here. I will push what we've done so far to GitHub.